Welcome back. This is Mrs. Rubright with Advanced Algebra, and today we are learning 2.2, solving inequalities by adding or subtracting. So, properties of inequality. You have solved addition and subtraction equations by performing inverse operations that isolate the variable on one side. The value of the other side is the solution. Inequalities involving addition and subtraction can be solved similarly using the following inequality properties. These properties are also true for greater than or equal to and less than or equal to. So as addition property of inequality. So as long as you're adding the same thing to both sides, you're staying proportional. As long as you're subtracting the same thing from both sides, you're staying proportional. So solve it just like you would a normal equation. The only difference is when you're multiplying or dividing both sides of an inequality by a negative number, you flip the inequality symbol. And that's the only difference. So, how do the addition and subtraction properties of inequalities compare to the addition and subtraction properties of an equality? You do it exactly the same. You use inverse operations to isolate the variables. The variable. Most linear inequalities have infinitely many solutions. When using set notation, it is not possible to list all solutions in the brackets. The solution x is less than 1 in set notation is, so it looks like this, x such that x is less than or equal to 1. So if I was going to graph this, I have my 0, I have my 1. It's or equal to, so it's a closed dot. And then I use the arrow trick. As long as your x is on the left, you can use the arrow trick. The variable has to be on the left, then you can use the arrow trick. Look. You shade that way. So all values that are less than or equal to 1 are solutions. A number line graph can be represented, a number line graph can be used to represent the solution set of a linear inequality. So when you have less than or greater than, it's an open circle. It's open. When you have less than or equal to or greater than or equal to, it is a closed dot. Okay? And you shade the part of the solution set that qualifies. So you guys see this arrow trick? We're shading this way. Arrow trick, shading this way. You guys see how these symbols, as long as your variable is written on the left, the symbols point in the direction that you shade. Does this make sense? You guys like that arrow trick? It's definitely a nice trick. Write the solution set using set notation. Graph your solution. All right, so we have x minus 3 is less than 2. X minus 3, we're going to add 3 to both sides, and that's the addition property of equality, or in this case, the addition property of inequality, right? Because it's not an equal sign, it's an inequality symbol. So when I do that, what do I get? So I'm adding 3 to both sides, right? These are going to cancel out, and I'm going to get x is less than 5. And all I do is I just simplified it. I just performed that operation. So write the solution set using set notation. So x such that, right? X such that x is less than 5. How would I graph this? Open dot on the 5. Arrow trick says I shade this way, towards the negative numbers. Let's try another one. I have my equation. I need to add 5 to both sides, which is the addition property of inequality. When I simplify that, I get x is greater than or equal to 2. How do I write that? X such that x is greater than or equal to 2. Open dot or closed dot on my 2? Closed, or equal to, it includes it. Arrow trick says I'm going towards the positive numbers. X is greater than or equal to 2. Is 5 in the solution set of the inequality in part A? No. It's an open dot. So 5.001 is, or not 5.001, it's not greater than, it's less than. So 4.999 is, but 5.0 is not a solution. Suppose the inequality symbol in part A had been greater than. Describe the solution set. So then your solution set would have been x such that x is greater than 5, which would be all numbers greater than 5. So not 5, but 5.001 would be a solution. Suppose the inequality symbol in part B had been less than or equal to. So then that would have been x such that x is less than or equal to 2. The solutions would be numbers, all numbers or values, less than or equal to 2. This making sense? Okay. Solve, write the solution using the solution set, graph your solution. X plus 4 is greater than 3, so we need to subtract 4 from both sides. Subtraction property of inequality. X is greater than negative 1. X such that X is greater than negative 1. Open or close dot? Open. There's not an or equal to. It's just greater than. Arrow going to the left or the right? Right, towards those positive numbers. Subtract 2 on both sides. X is less than or equal to negative 3. X such that X is less than or equal to negative 3. Closed or open dot? Closed. It can also be negative 3. It is a solution. And we shade towards the negative numbers. Is negative 3 a solution set of the inequality in part B? Is negative 3 included? Yes. Because it's or equal to. Suppose the inequality symbol in A had been greater than or equal to. Describe the solution set. Then it would include negative 1. Suppose the inequality symbol in part B had been less than. Then it would not include negative 3. Make sense? So it would have been, it would have been all numbers less than negative 3. Okay. So, let's just do like 2 of these. So, which 2 do y'all want to do? Do you care? How about 1 and 3? So we're going to subtract 1 from both sides, which will leave us with x is less than or equal to -3. Close dot on the -3, arrow going this way. So now I want you guys to try number 2. Oh, and they want it in set notation. Try number 2 and write it in set notation. When you're done, look up and check your answer. All right. For 3, we would just subtract 6 on both sides. X is less than 0. So x such that x is less than 0. Open dot on the 0. Arrow going this way. Try number 4. And look up and see if you got the same. You guys okay on that one? And I guess we might as well do the last one. Alright, so your assignment on this one is page 83 and 84. Pages 83 and 84 you will do for homework. I hope you enjoyed the lesson on 2.2, solving inequalities by adding or subtracting, and we will see you next time. Have a great day.